Good morning, everyone. I am Cycle Lau. We are Group 13. Today, I'll be presenting our object-oriented system analysis and design for Pos Malaysia Berhad. Our project focuses on the distribution logistic management system for DLMS. We designed this system to help modernize the delivery infrastructure for our SDD 2201 module. To start, let's look at the specific problem we found while researching the current situation. Through our online research and document analysis of current logistic trend, we identified three main issues at Pos Malaysia. First, they are dealing with fragmented legacy system that still rely on manual route planning. Second, there is a lack of real-time tracking, which lead to delay and wasted fuel. Finally, with over 600 service points, the system gets overwhelmed during peak e-commerce season. To face it, we propose the DMLS, a unified platform built using object-oriented methodology. Key features include AI route optimization to speed up delivery by 25% and offline capable mobile app for the 2000 plus driver. We gather our requirement by analysis and analyzing industrial document and existing system layout available online. We have classified this system into three parts: TPS for daily transaction, MIS for report, and DSS for the AI route optimization. Now that we have covered the requirement, let's look at how the system actually functions in our use case analysis. For our analysis, we identify five main actors: the customer, warehouse clerk, courier, logistic coordinator, and branch manager. Look at our core use cases: registering and sorting. When a clerk registers a parcel, the system automatically includes the sort parcel function. Smart routing. When a route is assigned, our system uses an extended relationship to optimize route using AI. Delivery update. Once a courier confirms a delivery, the system can extend to send a notification to the customer. These diagrams show how everyone stays connected. The manager can monitor everything via a dashboard, while the system handles the heavy lifting of data journey and route planning. This analysis form the base for our system design. I will now pass it over to my teammate to explain the rest of our slide. Thank you.
Everyone, today I will continue to present about the sequence diagram. First, let me explain what is a sequence diagram is. A sequence diagram is a type of UML diagram that show how different parts of a system interact with each other. It focuses on the order of action, means it shows what happened first and next, the last of the system. The purpose of a sequence diagram is to help us understand how a system works. It shows the communication between different objects in a clear way. Because of this, it is very useful for system analysis and design. Now let's look at the main components. First is the actor, which is usually the user or actual system. Then we have objects, which are the parts inside the system. Next is the lifeline, which show how long an object exists during the process. Messages are the communication between objects. And finally, the action bar show when an object is active. All these components help us understand the system step by step. Here is an example how a sequence diagram works. First, the user enter username and password, and then the system checks the information. After that, the system sends a respond back to the user. This diagram clearly shows the process in order. Next is the collaboration diagram. This diagram is also part of UML, but it's a bit different. It focuses more on how objects are connected to each other, not the time order. The messages are usually numbered to show the sequence of interaction. There are several advantages of using sequence diagram. They are easy to understand and follow. They show the process step by step. They also help developers communicate better when designing a system. In conclusion, sequence diagrams are very useful in system analysis and design. They help us clearly see how the system works and how different parts interact. Because of this, systems are an important tool in system development. Thank you.
Hello everyone, I'm Yao Yuxing. The following part explains the system issues, proposed solution, key benefits, and activity diagrams. First is the system issues and the proposed solution. In the current system, there are three main problems: manual registration, slow checking, and inefficient routing. To solve this, the DLMIS is proposed. It uses GPS tracking, auto-routing, and real-time notifications. These features improve efficiency and customer satisfaction. Next are the key benefits of DLMIs. The system provides faster delivery, lower cost, and better customer satisfaction. Automation also reduces manual work and improves efficiency. Next is the parcel registration process. The process starts when a customer brings a parcel to the counter. Staff enters parcel details, and the system checks the information. If valid, the system generates a parcel number and a barcode. A label is printed, data is stored, and a receipt is issued. This improves speed and reduces human error. Next is the route optimization process. The system collects delivery data, including orders, vehicles, drivers, and traffic. Then it analyzes and generates the best route. If needed, the route can be adjusted manually. Finally, the route is assigned and the schedule is updated. This improves delivery efficiency. Finally, the real-time checking process. The process starts when delivery begins. The mobile application sends GPS data to the system. The system updates parcel status, and customers can check location and delivery time. If issues occur, the system sends notifications. After delivery, the status is updated to delivered. This improves checking accuracy and visibility. That's all for my part. Thank you.
Hi everyone, today I am presenting the Digital Logistic Management System DLMS for DLMS. This system is designed to track and manage parcel from the movement they arrive at the warehouse until they reach to the customer's door. So first we can move to system actor. We have 5 main groups of people or actors using this system. First, customer and warehouse clerk. They handle the initial parcel registration. Logistic coordinators, they plan the delivery path. Courier, they are on the road tracking and delivering packages. And the third is branch manager. They use two dashboard to watch the overall performance of KPIs. Then the second move towards our second slide. Here is how it works. So the process is simple. First, we register the parcel into the system. Then the clerk sort them by where they are going, and then once sorted, the coordinator assign a route. So the next is the courier then courier then take over the track and finally confirm the delivery. So we can move forward. Our last slides, it's smart features like we also built in some smart logic like a mandatory step. You cannot sort a parcel unless it's already been registered. Then we can move to second one, optional extras. We use AI to optimize route for faster delivery. And then handling problem. If delivery fails, the system automatically switch to a failed delivery mode to schedule a redelivery. Now we can move towards the conclusion. So in short, this system makes sure every parcel is accounted for and every delivery is as efficient as possible. Thank you very much, everyone, for listening me.
Hello, good day, everyone. My name is Dinsan, and this is my part. I will present the purpose of the user interface design and the conclusions of our proposed distribution logistic management system, or DLMS, for the POS under POS Malaysia Berhad. The main purpose of this design is to create a system that can solve operational weakness found in the current logistic process. At the moment, POS state faces several problems such as manual routing planning, fragmented inventory tracking, delay in operations, and reactive customer notifications. Because of these issues, delivery performance customer satisfaction can be affected. So our proposed DLMS is designed to improve efficiency, visibility, and service quality through a more modern digital system. This user interface design focuses on three major modules, each built for different users. The first is the operations dashboard. This is a web-based interface for manager, administrator, and coordinator. It helps them monitor key performance indicator, track live vehicle location, check parcel status, and respond to system alerts. With this dashboard, decision makers can quickly identify delays, route problems, or performance issues across branches. The second is the client portal. This interface is designed for customers so they can track their parcel in real time, manage delivery preference, contact the assigned courier, and review delivery history. This is important because customers today expect more transparency and faster updates instead of waiting for delay or reactive notification. They can receive proactive information about their parcel status. And the third module is driver mobile application. This mobile app is specially designed for delivery personnel. It allows courier to view assigned stock, scan barcode or QR code, confirm deliveries, and report failed attempts. One of the most important features is offline support, which means the app can stay functioning even when the internet connection is weak, and the data will sign automatically once connection is restored. This is very useful for real delivery situation. In conclusion, the proposed DMS is expected to bring several important outcomes to POS Malaysia. First, it aims to achieve a 25% reduction in delivery times by improving logistic coordination and route planning. Second, it will support fuel cost optimization through intelligent routing. It helps the company reduce unnecessary travel and improve efficiency. Third, it will provide real-time visibility for customers so they can track parcels more accurately and receive proactive updates. Finally, the system is designed with scalable infrastructure to support 15% annual e-commerce growth, which is